Red Hat OpenShift Service on AWS is a managed offering that allows you to draw down on negotiated spending commitments with AWS while leveraging the experience of Red Hat SREs who manage the platform as you focus on your workloads. You get started right in the AWS console, search for OpenShift, and then check that it is enabled in your account, which will do some very basic setup. Then you'll be walked through the remaining steps, which begins by downloading the ROSA command line client and an API token from the Red Hat Hybrid Cloud Console. Next, you'll move on to the command line, where you will ROSA login using the token. After logging in, ROSA init will perform some basic verification of your AWS account, ensuring you have adequate privileges and quota to proceed. Finally, we'll create the cluster, which will progress in the background. We sped that up, so now we can check the log to confirm that the cluster has been successfully deployed. Now that we have scaled our infrastructure to include a ROSA cluster, let's integrate it with our existing enterprise identity provider. First, I'll use the ROSA CLI to create an admin user that is local to the cluster. This user will remain available should our identity provider have any accessibility issues. ROSA integrates with your existing identity provider. In this case, we will use GitHub. We will identify a GitHub organization, the members of which will be allowed to log in. The command outputs a URL that takes us to GitHub, where we can generate a client ID and secret. After pasting those values back into the command line, ROSA completes the identity provider setup. The new identity provider, called GitHub One, will be available when logging into the ROSA Clusters console. The first time through, we'll have to enable access. Now that you're authenticated to OpenShift, role-based access control may be applied to establish appropriate authorization within the cluster. Basic cluster management, recommendations, and customer support can be accessed in the OpenShift Cluster Manager. OCM can be found in the Red Hat Hybrid Cloud Console alongside familiar tools like Red Hat Insights. OpenShift Cluster Manager utilizes telemetry reporting from clusters to identify issues. When we dive into this Azure cluster, we can see details and resource usage. In the Monitoring tab, cluster alerts are relayed, like this warning that no alert receivers are configured on the cluster. We have the ability to control who has access to this cluster in OCM, and finally you have direct access to relevant support cases for this cluster. Continuing down the main menu, the Overview tab gives us a high-level view of all the OpenShift clusters in our fleet, detailing their resource utilization, and a summary of advisory recommendations, which we'll look at momentarily. The Releases tab provides information on the latest versions of OpenShift, including links to the release notes. Downloads is where you can quickly find any tools that you may need to interact with OpenShift, ROSA, services like Tekton, or developer tools like ODO, Helm, or the Operator SDK. And of course, there's the OpenShift installer for self-managed cluster installation. The advisor applies machine learning to telemetry data and tells us when there's something that could be either a little bit wrong or against recommendation with our cluster. Here we're being reminded that the Prometheus metrics are not persisted on this new Azure cluster. And finally, you can report on your subscription usage and allocations over time. Importing our ROSA cluster to Red Hat Advanced Cluster Management for Kubernetes adds benefits including fleet-wide application lifecycle management, governance and observability, and centralized alerting. ACM has the ability to discover clusters in the OpenShift Cluster Manager, so importing an existing cluster is easy. Just enter the API URL and a token, and after a few moments, ACM gathers all the details of our ROSA cluster and begins to collect metrics. I'll show you how we can take advantage of this with policies to ensure all of our clusters are consistently managed. But first, What if some of our clusters are still based on technologies like EKS, AKS, or GKE? Well, that's not a problem. Red Hat Advanced Cluster Management for Kubernetes provides benefits for all types of Kubernetes clusters. Let's bring an EKS cluster under management, where we can ensure its workloads are also first-class citizens. This time, we'll generate a command to instruct the EKS cluster to enroll with the ACM hub. It's basically an encoded script which will deploy the pods for the agent and install the open cluster management APIs that ACM will leverage to manage the cluster. Back in the console, after a few moments, ACM will begin to show details of the nodes which make up the cluster. OpenShift includes Prometheus metrics and dashboards out of the box. If we ensure the Kubernetes metrics server is installed on EKS, the Observability add-on will scrape these metrics and store them on the ACM hub. Let me show you what that looks like. The ACM Observability add-on uses tools like Prometheus, Thanos, and Grafana to provide a single pane of glass for observability. Additionally, Alert Manager enables centralized alerting for events. Metrics are gathered from OpenShift and other Kubernetes environments and saved to object storage, where they may be preserved or exported to other systems. Configurable dashboards enable fleet-wide visibility and the drilling down into individual namespaces on any cluster. ACM provides application lifecycle features, enabling the deployment of applications from object storage, Helm charts, or Git repositories. We can use this feature to deploy our governance policies. We're starting out with none. Now let's create an application to deploy our policies from Git. We'll first create a subscription type application, give it a name, and give it a namespace to live. And as we fill out this form, you can see the values are populated in the YAML on the right-hand side. Once we've selected a Git repository, we can choose the appropriate branch and path within that Git repository to deploy the application from. Additional parameters enable us to decide when this application should be deployed and where it should be deployed, to which clusters. We're going to deploy to the local cluster, which is another name for the hub cluster. Since these values are in YAML, we can save them. We can store them in Git, and then use a GitOps flow to deploy this application. After deployed, we can look at the topology view of the application we just created. We can see that it was deployed to the local cluster, and we can see that it created these resources at the bottom, including these 4 policies. What are those policies for, and how do we take advantage of them? Let's dive into that. Red Hat Advanced Cluster Management enables consistent, policy-driven configuration across your entire Kubernetes fleet. The policies we just subscribed to ensure that the Red Hat Advanced Cluster Security Operator is installed, and that all clusters are enrolled to be secured. We're informed by the red icon that the ROSA cluster is in violation of policy and lacks the operator. So let's follow the link at the top to the Git repo we previously subscribed to. We can automate the remediation of these violations. First, recall the branch and the directory we previously chose to deploy the policies from. And if we look within this policy, we can see that the remediation action is set to inform. A configuration policy has the ability to remediate violations by creating missing resources. Let's make a change using our normal GitOps flow of code review and an audible merge request, detailing what has changed. We're going to change the remediation action from inform to enforce. Then push those changes to GitHub and create and merge our code back into the demo branch. We'll give a description to the change we just made. At this point, we would do a code review with our peers. We're going to skip that and merge the branch. Now that the Git repository has changed, our application will synchronize and update to the latest version on a schedule, but let's trigger that immediately. With the policies now synchronized and set to enforce, let's watch as they are automatically remediated within a few moments. Notice that the namespace has been created, the operator group has been created, and the subscription has been created. Now that the operator is installed, another policy will duplicate the secrets necessary for the cluster to enroll with ACS. On the overview page, we can now see that all of our TofuOrg standards are in compliance. And here's a sneak peek to show us that ACS has already started securing our clusters. We'll talk more about that in the next section.